our course, and then final exam, and then what else? Whatever else you want to talk about. Okay, so let me bring up the final exam page first. So final exam page has been on the website since the first day of class. If you have not yet gone through it, please do so. Please read everything on this page. First thing I would state is the first point, which says final exam is mandatory. It's not optional. It's worth 20% of your overall grade. So if you're happy with your grade without that 20%, meaning C plus or B minus, and you don't want to take the final exam, that's up to each individual student. Okay, so it's not going to be dropped. There is no option of dropping it. The students don't take the exam, it'll be as if they didn't submit an assignment. That's all. Okay, all final exams are in person. You have to present a valid Cal Poly ID to take an exam and then return it back to me. So you sign in and sign out. Again, this is to ensure that every student who is taking the exam is a student of the class, and then also ensures that the exam, when you hand it over, is returned to the instructor. And so kind of like, chain of custody, so to speak. Let's see, there are 4 options for students to take the exam. These are the official times. These are decided by the university well in advance of the quarter, right? So these are not done by us. The exam takes place according to your scheduled class time in this classroom on a Friday. Okay, your exam is on a Friday. It's basically the last day of finals week. The option students have is you can take the exam on a Wednesday or you can take it on a Monday, which several students do opt to do that. And then there's also an option to take the exam on the Saturday before finals week, which is basically the Saturday after 8 days from today. And that is not in this classroom. That is in building 20, room 126. That's where you take the labs. 130 or 126, that's room number 126. That's where we'll hold the exam. Yes. For any class, any student. So I'm going to explain that. So the Saturday final, again, it's optional, right? The only mandatory part is, of course, whenever the exam takes place for your scheduled time. If you want, if you don't want to take any other option, you just show up and at that time, that's it. You show up on a Friday, you take the exam and you're done. If you do wish to take any of the other options, then you have to let me know. So if you wish to take it on the Wednesday or Monday, you have to let me know. There's a survey form at the end of this page. Again, some students filled it out in the first week of class. And so if you wish to take it on a Monday or Wednesday, you do have to provide a reason. If you wish to take it on a Saturday, you don't have to provide a reason. You just let me know in that form that you are coming on Saturday. So any student from any section can come on a Saturday. I will have plenty of space across both rooms, so space is not going to be a problem. But there is a survey at the end of this page. No reason needed for Saturday option. Just let me know. So I need to know that so I can print out that many exams. It is okay if a student signs up for Saturday and does not show up. That is fine. I can deal with an extra exam. But if you show up without letting me know and I don't have enough exams, then you'll have, it comes out of your exam time. Let's see. Does that answer your question? No, I will update. And so that's going to be my next talking point is, so Saturday finals is pretty much considered unlimited space. Let's say it that way, because I've never run into a problem where I have more students than the number of seats. Saturday, usually nobody is here on campus. We have plenty of space across the entire building. So I'd be able to accommodate all 120 students if they wish to take the exam on a Saturday. Okay, that's the first thing. Now, in this classroom, every section, I have 40 students. And let's assume all 40 decide to take the final, right? Nobody's skipping it. The problem is this room does not physically have that many seats or 40. There's only about 40 or 42 or 43 seats, I believe. I see 1, 2, 3, 4, 5. 7, 5, 35, 35 and 8, 43 seats in the classroom. Okay. So depending on how many students from each section decide to take the Saturday final, that many spots I will have available on Monday, Wednesday, and Friday. Make sense, right? So your exam is on Friday. Let's say the Monday section, whoever's exam is on a Monday decides to, let's say that's the 11 o'clock section. 5 students decide to take the exam on a Saturday, and I have 5 extra seats available on that Monday. So typically, I've never had issues accommodating students, but I usually have like a 7 o'clock final, and so there'll be very few students choosing to, which I understand. Who wants to get up at 6 o'clock and come give a final exam at 7 in the morning? So that will be the lowest attended final, the 7 o'clock in the morning, Wednesday one. And so a lot of students from that Wednesday exam would decide to either go Saturday or they will decide to come on a Wednesday or Friday. And so then it would be first come, first serve, just because of the the lack of physical seats in the classroom. Other than that, I have no problem accommodating anyone. So that's the thing. So that's why I stated there on the first day of class also that if you wish to take an alternate time, just let me know as soon as possible. It's first come, first serve. I will try and see if I can pull extra chairs from different classrooms, but that's also not always guaranteed. So that's the option regards to the dates, right? All right, any questions? Okay, so then, so the final exam information, worth 20% of your overall grade. If I ask you to solve a problem using a particular method, then you have to show me that particular method. If you use something else to solve the problem, even if it is the correct answer, I have no basis for judgment. I have no basis for assessment. ABET, we are accredited by the ABET board, ABET, right? And so we have the expected course outcomes from every syllabus that is presented to ABET. Then we check. ABET actually reviews the student work. So they look at it, they look at the syllabus. These are the topics in the syllabus, whether the instructor provided the knowledge of those topics, and then the basis for assessment would be. So, if I ask to solve using node voltage analysis, then I have to present an example where a student solves it using node voltage analysis. And that's the thing you have to do. So if you don't show me your knowledge of NVA and you use superposition to solve it, I have no basis for assessment. I don't know whether you can do NVA or not. It'll be like a 0. Okay. So, and this goes for all classes. Doesn't matter whether it's engineering or English or history, or it doesn't really matter what it is. It's just generic advice for any class, any course you might take anytime. Okay. So if I ask you to solve it using a particular method, then you have to show me use that method. And do it step by step. I like to award partial credit, meaning if you show me all the steps, your methods, your approach, everything is correct, and you make an error in your calculation, so your final answer is incorrect, well, depending on where you made the error in the process, you will receive 70, 80, even 90%. So if you did everything correctly and you only made an error in the final answer, you might just lose like 10%. Okay, 1 or 2 points, not the entire 10 points. So I lean towards the student in that sense, because you have showed me the work, you did make an error in calculation, so there is a penalty, but it's not heavy. Okay, and units, of course, missing and incorrect units, points will be deducted. This page will be updated, right? So there are some things that I was thinking over last night, so I haven't had a chance yet to update this page. This will be updated later tonight or maybe over the weekend, okay? So I will update this page. All right, topics. First problem, 30 to 35 points, guaranteed problem. 4 pages long, covers everything from chapters 1 and 2. Ohm's law, KVL, KCL, power and energy, resistors in series parallel, voltage current division, NVA, MCA, and Thevenin-Norton analysis. And I will go over everyone in just a review in just a few minutes. That forms the bulk of your exam. Okay, that is the bulk of your exam. Then second problem is chapter 3, physical construction of capacitor and inductor, and capacitors and inductors in series and parallel. Piecewise linear analysis, I'm kind of 50-50 right now. Again, I will decide in a couple of days and I will update this page. Okay. So it may or may not be on the final exam. And then one more problem about transient analysis. And that's it. That's it. Chapter 6 was frequency response. So I'm not going to assess that separately. That was quiz number 8. If I do have actually, you know what? I will not have any problems from chapter 6. What I will have about filters is concept-based short answer questions. Okay, concept-based short answer questions. And then AC analysis and AC power tested and assessed on quiz number 7, and then quiz number 9 that is coming up. Okay, so quiz number 9 based primarily on AC power. It's not going to test you completely on AC analysis, but you do need a concept understanding and may need to do some calculations based on AC analysis. Meaning, if you have voltage current, then you need to know how to manipulate that with the impedances and then calculate AC power. So let's say maybe 70-30, 75-25, leaning heavily towards AC power, and the rest would be like AC analysis. Okay. So quiz number 9, again, about 30 minutes, I would say 30-35 minutes, coming up on Monday. Okay. And I will post that also later this afternoon. But again, everybody should be aware of that by now. I've been talking about it since the last few classes. So again, I will not test AC analysis and AC power separately on the final exam. You get done with quiz 9 and that's it, done. And then frequency response and filters, again, we tested on quiz 8. So I won't test the problems again, but just short answer questions. Sounds good? Okay. I think hearing this, a lot more students might decide to take the exam on a Saturday. Prep, in-class solved examples, quizzes, homework, lecture notes, videos. And then of course, I'm here all through next week, every day. I'm here all through finals week, almost every day. And then I'll be available over the weekends also. Equation sheet. Students are not permitted to bring in one equation sheet. That is incorrect. I'm going to take this out because it is open book, open notes. So I haven't yet decided if the open notes is going to allow you an open laptop or open electronic devices. Because obviously with 30, 35, 40 students in a class, I cannot monitor what students are doing. I know I permitted that during the quizzes, but I haven't yet decided what I'm going to do if I'm going to have a laptop or a tablet allowed for the final exam. Right now, I'm kind of leaning towards no electronic devices, but you can have unlimited number of physical notes. You can print out whatever you want, bring in anything you want. So I'm more likely, I'm leaning towards that. So again, equation sheet, not required. You can bring in as many notes as you want. Okay. You have all the tools at your disposal. Use the tools, show me your best work. And then the survey, just fill out the survey. Again, as I said, I just need to know if students are showing up on a Saturday or not. The more students who show up on Saturday, the more we can be flexible with Monday, Wednesday, Friday scheduling. Okay. And again, this is dynamic. It's changing constantly. So right now, I think students, 9 o'clock students might, fill out something today. Students from today's section, this section will fill it out. And so it is the responses I receive over the weekend, all through next week, will determine how many seats are available. So as and when I know how many seats are available, then I can provide a definite answer whether students can take Monday, Wednesday, or Friday, alternate times. So if you don't hear from me, let's say Monday, Tuesday, wait until like Tuesday of next week. If you have requested like an alternate time, like if you requested Monday, Wednesday, Friday, what is your time? Your time is Friday, right? So if you requested a Monday or a Wednesday, then yeah, just wait until Tuesday, find out. Because a lot of students will submit this form on over the weekend. I think it's safe to assume that anyone who wishes to take the exam at 7 o'clock on a Wednesday, there will be plenty of seats. I think there'll be plenty of seats on 7 o'clock in the morning. So, all right, let's see. Any questions? I will update the page again, and you'll have all that information available to you. Yes. Nowhere. It's not shown anywhere. No. It's private. It's not distributed to anyone. It's not shown to anyone. That I don't know. I mean, I can see the responses, but I don't know if, because it's an anonymous, no, it's not anonymous in that sense. I guess anybody can fill it out. You don't need to have a login to submit this form. Anybody can fill it out from anywhere. No. No. I do recall seeing your submission, your name on there. Yeah. So it's there. Okay. Chapter 1, introduction. Chapters 1 and 2, that's the bulk of your final exam. Okay. It's the bulk of your final exam. So let's see. Three main things from this chapter is Ohm's law, and then KVL and KCL. These are the only three laws and techniques that we use for everything. And then, of course, the power equation, P equals VI. Okay. Everything else is built on these equations. V equals IR, Ohm's law, KCL, and KVL. Everything else is based on these equations. The entire course, all of circuit analysis. And that is, of course, also the reason why we had all those homework assignments in the first week. Yes. Yes. And I will go over it. So it's Thevenin-Norton, if you all don't recall or remember, is a concept, is a theory. It's not an analysis technique. So you're taking all the techniques and applying it to a theorem. So Thevenin theorem and Norton theorem. And so there'll be one circuit. You'll be asked to do or determine the Thevenin and Norton theorems, do the Thevenin-Norton analysis, show me the equivalent circuits. And as part of that application towards Norton and the Thevenin theorem, you will use certain analysis techniques. That's why it tests everything from chapters 1 and 2. So it's not going to be like a separate circuit for every single problem, which actually, one large problem sounds scary in that sense, but it's actually easier because you're dealing with the same circuit throughout. It's not a different circuit for every single topic. So Ohm's law, KVL, KCL, and power. These are the four important concepts from the first chapter, right? And everything else, of course, passive reference configuration. All of that is, of course, important concepts. And then we get to chapter 2. And in chapter 2, we begin resistive circuit analysis. First up was resistors in series. And by now, of course, every student should be an expert in doing these. Resistors in series, resistors in parallel, and then combining all resistors in series and parallel down to one single REQ. Fundamental concepts. Okay, fundamental concepts. And again, this also requires a little bit of knowledge of Ohm's law. And then we take these concepts and develop our first analysis technique, which is series parallel equivalent analysis. Okay, this is not something I am going to test or assess separately. But of course, it is something that students should be aware of. This is one of the most fundamental, most basic circuit analysis techniques, where you take a large resistive network, reduce it down to one single resistance, apply Ohm's law, KVL, KCL as the need may be, and then expand the circuit back up. This also would be useful for AC analysis and AC power, right? This is what we used. So this technique, again, I will not assess it separately, but maybe if I have superposition in there, then this is part of superposition. This is a technique you can apply to do that. Okay. Then we had voltage division and we had current division. Both of them are guaranteed to be on their final exam. Again, it's there on the final exam page. It's part of that one big problem. It's not separately. It's part of that big problem, but it's guaranteed to be there on the final exam. Okay. And voltage and current division are derived from Ohm's law. They are shortcuts. Voltage division and current division are shortcuts that are derived from Ohm's law. So you have to apply these techniques directly. In the exam, you cannot sit there and derive Ohm's law and then say that that is voltage division. That would not be correct. Okay. So if I ask you voltage division, you have to show me voltage division. Then node voltage analysis and mesh current analysis, guaranteed topics on the final exam. You will do this as part of your Thevenin-Norton analysis. Okay, and again, this is already there on the final exam page. So NVA requires application of KCL and Ohm's law. Again, it's a technique that's built on KCL and Ohm's law. Mesh current analysis, or MCA, is built on application of KVL and Ohm's law. So again, same three equations, same three laws from chapter 1 is what you're using to build on these new analysis techniques. So MCA and NVA both require KVL, KCL, and Ohm's law. Guaranteed on the final exam, and use this. Consider these steps as the rubric. Okay, these steps should be shown on the final exam. If each step is shown, then this is how it will be graded. Okay, if any of these are missing, you will make an error and you will also lose points. So consider these as the rubric, as your guidelines. All right, let's see. That is node voltage analysis. Then we have mesh current analysis. Again, same thing here. Consider this as the rubric, right? Summary steps. Do not worry about super nodes and super meshes, okay? I'm not going to assess them separately. If you wish to apply super nodes and super meshes, it's fine. You can do so as part of your analysis, but I am not going to assess them separately. And again, super node and super mesh is also a shortcut, right? If you have multiple voltage sources and multiple current sources in a circuit, that's when we use super node or super mesh. So again, these are also shortcuts. I will not assess them separately. Then we get into, there's superposition principle. I have not yet decided whether I'm going to assess this separately or not. I'm leaning 50-50, so I'll let you know. And then equivalent circuits, Thevenin and Norton equivalent circuits, okay? This is the whole purpose of chapter 2. Again, Thevenin theorem and Norton theorem, that will be the culmination of the entire analysis that you perform. Make no mistake, the majority of the points will be attributed to, not attributed, will be allocated to the node voltage analysis and mesh current analysis. The results you obtain from those two analysis techniques, you will apply to draw and show me the Thevenin and Norton circuits. Okay. So NVA and MCA forms the major chunk of that problem. But again, you need to know these concepts. If you don't have this concept down, then you are going to lose points. Okay, that's the summary slides. Equivalent circuits for everything. Solve examples. Source transformation, I'm not going to assess separately. If you wish to use this as part of your analysis, that is fine. Okay. I try to stay away from source transformation personally, but I've seen students attempt it in one of my final exams. 2 or 3 students usually attempt it. So if you wish to use it, that's fine, but I personally stay away from it, and I'm not going to assess your knowledge on source transformations. And then maximum power transfer theorem, that's also not going to be on the final. Okay, chapter 3. Chapter 3, inductance and capacitance. I've already stated on the final exam page, I'm only going to test or assess physical construction of the inductor or physical construction of the capacitor. Okay, those 2 slides. So physical construction of capacitor or inductor, and then capacitors in series and parallel. Okay, capacitors and inductors in series or parallel. So those concepts will be tested. Piecewise linear analysis. Again, I haven't decided either way. So if I do have it, it'll be like a short piece, not very long. And I will update that page again over this weekend. And that's it for chapter 3. And then chapter 4, one problem or transient analysis. This is all you need to know. This one slide. Whether it's charging, whether it's discharging, whether it's an inductor, or whether it's capacitor, your job as an engineer is to determine 3 quantities: the starting voltage or current, the ending voltage or current, and the transition time it takes for the energy transfer to take place. That's it. This is the only equation. Okay. So make sure you know how to use and implement this equation. Any questions? This, of course, universal time constant chart and the universal time constant values you should be familiar with. These are, of course, derived from e raised to -1, e raised to -2, 3, 4, 5. So you don't have to like memorize these or anything, but again, even after the class ends and you're on your way to working in the industry, you should know what it is. Okay, well, that's it. That's the final exam. Not going to assess you any more than this. Quiz 9, as I said, AC power, AC analysis. Quiz 8 was filters. Filters, I will just ask short answer questions based on concepts, so conceptual based. Problems, primarily leading towards chapters 1 and 2. I mean, that's it. Sounds fair? I'm expecting Saturday responses to shoot up after this. So 9 quizzes, waiting time about 15 minutes on average, I would say. That's more than 2 midterms. 9 quizzes would be more than 2 midterms on average, the amount of time you spent. and then we have the final exam. So I think that's a good assessment throughout the quarter. At least that's what I feel. I don't know how students feel about it. I will be available all through finals week. I'll be available all through next week. I'm here every single day, 8 to 5. Some days I'm here 8 to 6. So this is the end of the quarter, except we'll meet one more time on Monday, next Monday. Wednesday, Friday, enjoy your time. Catch up on sleep if you want. Catch up on your pending work, senior project, end of the year projects, extra studying time. I will be available in my office next week. So, but this is the last time for in-class instruction. Okay. If anyone has questions, feel free to ask. The floor is open. Otherwise, we'll end class today. I mean, we'll end class here today at this point. Yes. Which quiz? No. Question being asked was decibels. Decibels was chapter 6. So maybe not on the final exam, but definitely not for quiz on Monday. Quiz on Monday will solely be on AC power, and then some portion of it might deal with AC analysis, where you'd have to find voltage, current, and impedances, but mostly just about AC power. Yes. Something like that. Yeah. Question being asked is, would it be like the homework where you're given some values and you have to draw the power triangle? It might be, it's, if you have the 2 solved examples that you were solved in class, and then you have the homework. And so it'd be something similar. Yeah. And what I'm going to also do is I'm going to add in a few extra problems for practice in the homework assignments. So what I will do is I'll add some problems to, I can't remember what homework it was for chapter 5. AC analysis was what, homework 15 or 16, I believe. And so I will add that. I will add a few problems in there, 2 or 3 problems. And then for AC power, I will add in like a couple more problems, just for practice, like no credit. Just if students want to practice, then they can use those problems. And I will post all of that in an announcement later this afternoon. I will be in my office till 2 o'clock today. From 2, well, I'll be in my office till 5 o'clock today, every day. But between 2 and 3, I'm attending a seminar in the building. I'll be in the building itself, but I'm attending a seminar. So I won't be in my office between 2 and 3. So if students want to stop by, they can come by between 1 and 2. Or between 3 and 5. Okay. All right. If there are no other questions, that's it. Hope you all learned something. And remember it after you're done. Mr. Ohm's law, that's good. How about KVL and KCL? Kirchhoff will be disappointed. Or Kirchhoff will be disappointed. All right. Don't forget to fill out the survey. Have a good weekend. I'll see you all on Monday.